This video is part of the MLA tutorial series. This goes through some of the basics of MLA and more advanced techniques on how you can use it to make great LabVIEW programs. Let's talk about the loops inside of an MLA application. The loops are the core of what makes the program work. So we've got a GUI loop on top. This is kind of a unique one. The purpose of it is to catch all of the GUI messages from the button presses and event changes, and then fire off messages to the other loops. The main workhorses of the program are these other loops that make up MLA. And they go on as long as you want them to, loop by loop. And a little bit of the philosophy behind that is using loops to do a functional component of your program. So here I've got an example, the top one here called process, and what it does is handle some general state information for the program. There's various states that it can cycle through: initializing, idle, system error, aborts. Now, in this case, this is a shell. There's nothing in this particular program that uses that. This is put in as an example for you to fill in as sort of a macro state machine for the state of your system. There's another similar one that's a worker loop called action, and it does things like read and write any files to load and save settings that you might have. Then we get into the actual loops of my program. In this case, I've got three main functional blocks, and they're basically device drivers for devices. I have a multiplexer, I have a DMM, and I have a power supply. And they have a very similar set of functions. And the way that that works is all the messages that this loop responds to define the behavior of, in this case, the mux. When the program starts, it calls the initialize function. In this case, we create the object that's going to handle our mux, and then we kick ourselves off to our own create state, which in this case makes a connection to the USB device, creates the object, and then it calls the function that will kick off the actual connection to the USB with the connect, and this is where it connects to the COM port. And then beyond that, you can reset, which opens all of the channels, and you can set a mux channel, which mux position you want. Now you'll notice all of the states here are this dot create, this dot connect, this dot reset, this dot set. That notation is echoed in all of the others. All of the implementations for each of these is this dot. And this is borrowed from C notation, where if you're inside of an object, you refer to yourself as this. So what's happening here is the message that's actually being sent, which you can see actually in this create, we send mux.connect. Mux is actually where the message is directed. Now this device, this is called the mux, this loop. What's happening here in the MLA message unbundler is that it is seeing that this message was sent to mux. It sees that it is the mux. So the message that it actually forms is this dot connect. That way we can always refer to our own messages with a this dot. We follow that same kind of pattern where each of the loops kind of does a functional block, provides essentially a device driver for an instrument. And then from the outside, we're able to send messages to them, just addressing them by whatever name we've given them. And that's how you use loops in MLA. Thanks for checking out this video. Make sure to watch the other videos in this tutorial series and click subscribe so you can catch all of the other instructional videos that we post.